All right, people at home, what's up? We're going to talk about net ionic equations. You'll understand this. I feel very confident. And yeah, my microphone that I wear is messed up. So I'm using the microphone on the Mevo and on the iPad here. So you have to turn me up on the headphones a little bit. I'm going to try to get the iPad a little bit closer to me. All right, here we go. Net ionic equations. Okay. So I talked to you at home and in school about what dissolving means, okay? What it means for something to be dissolved, okay? So let's take a look here. This is like a little pan of water, okay? I'm going to zoom in here for the people at home. All right. This is like a little pan of water, a little pot of water. And you may be getting ready to make some pasta, like I do frequently. And you may put some table salt in there, right? So we're going to take this table salt and bloop, drop it in the water. What happens is sodium chloride or table salt, that is soluble, correct? So here's what soluble means. It means that the water molecules tear the salt compound apart. And you end up with Na plus and Cl minus individually floating around in the water, right? Does that make sense? Now these guys are ions, right? Remember that term? An ion is a charged atom. So we're getting ready to talk about net ionic equations. And we're going to be talking about what's happening to these ions that are floating around in the water when we're mixing liquids in our test tubes, okay? And I'm going to make an Edpuzzle about this too, but you need to watch this video, people at home, so you can try the worksheet. All right. So let's go back. Let's go back, and then I will find a tissue to be my eraser. All right. So, if we had a chemical equation like this, all right, we're going to dump some sodium chloride in the water, and we're also going to dump some silver nitrate in the water. Or we're mixing two solutions, a solution of sodium chloride and a solution of silver nitrate. So it's important we understand these are aqueous, right? Both of these things on this side of the equation dissolve in water, right? Now, if these atoms are swimming around in the water, right? These atoms are swimming around in the water, then the sodium nitrate will not really connect. But the silver chloride will connect and make a precipitate, right? And you know that this is a precipitate from looking at your naming rules. So we always circle the precipitate, right? So we can balance this, and guess what? This one's the easy one. A 1, a 1, a 1, 1. Circle the precipitate. Aqueous, aqueous, aqueous precipitate. But let's talk about what this really means, okay? I just need to find a marker that will make a dark enough mark on this for me to explain it to you. It means that in the water here, in the water, the silver ions and the chlorine ions, that was silver chloride, right? The silver ions and the chloride, they clump together. Does that make sense? That's why they're the precipitate. That's why we see that. You saw me mix precipitates. If we poured those two together into the same test tube, then you would actually see silver chloride form, okay? Now, the other ions, the sodium and the nitrate, would still be floating around individually. Does that make sense to you? That should make sense to you, okay? So, a cool thing to do would be for me to actually do this. So, I'm going to try to fix the camera. So people at home, on the board is the equation. Sodium chloride and silver nitrate are mixed together. And to make sodium nitrate that's aqueous, see the sodium and the nitrate are separate. They're still dissolved. And it makes silver chloride that is a precipitate. Boom. The silver chloride is actually stuck together. It's actually a compound in the water. It's not individual ions, right? So we're going to do that. This is sodium chloride, okay? And this is silver nitrate. So when we actually mix them together, you see this white precipitate, okay? And that white precipitate is silver chloride. So this white precipitate is the silver chloride. Does that make sense? All right, so that's the point. That's what we're doing. Now let's talk about what the chemistry looks like when we put it on paper. All right? When we put this on paper, do y'all see my pink marker? I had a pink marker that wrote a little bit better than these markers I have. Okay. Oh well. So let's write this. Let's talk about what we would need to write down. Okay? All right. In a net ionic equation, you literally write down all of the ions that are in the water. Okay? So, sodium chloride, you have sodium chloride is aqueous. So you have a sodium positive atom and a chlorine negative atom. Everybody agree with that? Ion. And silver nitrate is aqueous. So you have a silver +1 and a nitrate -1. Now, after the reaction, see how sodium nitrate here is still aqueous? Then you have a sodium atom that is positive, a nitrate polyatomic ion that is negative, and what's the precipitate? Silver chloride, right? The AgCl is together. So you separate all of these out, right? And then the one that is your precipitate, you leave together. The one, that's why I have you circle it. This guy is still a compound in the water. Does that make sense? So this part of the equation is called the complete ionic equation because you have all of the ions that are floating around in the water. Okay? Now, when we write the net means only the ions that are actually doing something. If you have a net profit in your business, that means only the money you made minus your expenses, right? Like if I made $100 hauling dirt one day, but I spent $25 in gas, then my net profit's only $75, right? So the net equation is only what actually nets, only what actually happens. So check this out, and this is what you're going to like. The only thing that actually does anything are the silver and the chloride atoms, right? So to do the net, you just go by and you mark out anybody that's not silver or chloride. So you mark out sodium, you Ghostbusters it. All right, you leave chlorine because it's part of the product. You leave the silver. What about nitrate? Is it part of it? No, you mark it out. People at home, if you can't see that, I'm making the Ghostbusters symbol over it's funny, trust me. And then right here, sodium, mark that out. Nitrate, mark that out. So the net ionic equation is only this. A chlorine negative ion and a silver positive ion in the water get together to make silver chloride. This is actually the only thing that's happening in the water. Hush. All right. So that's the only thing that's happening in the water, right? So this right here, we made this silver chloride. The net ionic equation is just that a chlorine negative and a silver positive got together and made silver chloride. Okay? Now that took me 11 minutes to get through that one example. So stick with me. I'll just do one more, much more quickly. Okay? Let's try the next one down. The next one is iron 3 chloride and solid magnesium. So this is going to be a single replacement reaction, right? Everybody with me on that? This is just going to be a single replacement reaction. So iron 3 chloride is aqueous. Solid magnesium is going to make magnesium chloride and solid iron. First thing we would do is balance this, okay? So we're going to need to have, see there's a 3 there and a 2 there. So let's put a 3 there and a 2 there. That gives me 3 magnesiums and 2 irons. So if you balance this equation, which you must balance it first, 2, 3, 3, 2. Now remember the first example I did to you ended up just being 1, 1, 1, 1. So what? What are we making here? Iron, right? Iron is the product. So we're going to separate all of this out. 2 iron plus 3. How did I know that iron was plus 3? Because it's FeCl3. So you know this had to be iron 3. 2 iron atoms, and how many chlorines are right there? It says Cl3, right? But there's 2. So 2 irons and 6 chlorine negative ones. People at home, did you see what I did? The balance is 2 FeCl3. So that means there's really 6 of these chlorines here. So 2 irons with the plus 3 and 6 chlorines with the negative 1 plus 3 magnesiums, okay? And that magnesium is a solid, so you don't have to write a plus 2 on there. If you do write a plus 2, I'm not going to count it off. And then now we have 3 magnesium chloride. We have 3 magnesiums that are plus 2. And how many chlorines are right here? 3 times 2, so 6 chlorines that are negative 1. And now we have 2 ions. That's our precipitate, right? So take a good look at this. Pause your video at home. 2 ions that are plus 3. That's this part of this compound. And 6 chlorines that are negative 1. And there are 3 magnesiums in the water. So this magnesium, you don't have to write a plus 2 because it's not an ion. It's a solid atom. It's a solid material. It's not charged, okay? And then they produce 3 magnesium plus 2s because this is an aqueous compound, 6 chlorine negative ones, and 2 irons. So the net is only what you make. What's the only thing we're making? Iron. So really, you Ghostbusters out everybody that's not iron. And the whole thing is 2 iron plus 3 atoms end up making just 2 iron atoms that are solid. That's that. If you're at home and you want to see one more done that's a double, keep watching. If you don't, then cut it off and try the worksheet. I suggest that you keep working. Here we go. This will take me, I'm going to do this rather quickly. I'm going to do this in about 2 minutes. If you're at home, you can always play the video with me speaking at 1.25 speed, which just makes me seem really irritable, but it makes the video go by quicker. All right, lithium hydroxide and vanadium 3 chloride make lithium chloride and vanadium 3 hydroxide. Now, if you look, this is blank. Lithium chloride, you would look it up on your tables, that's aqueous. And vanadium hydroxide is actually a precipitate. Okay? You would look those up on your tables, you know how to do that. Okay. Let's balance this. We're going to need a 3 there and a 3 there. It's 3, 1, 3, 1. Okay? And now let's split these up. See how this is aqueous? There are 3 lithiums. What are the charge on that? +1. And there's 3 OHs with a -1 charge, right? And there's a vanadium that's +3 and 3 chlorines that are -1, and they produce, all right, see how lithium chloride here is aqueous, right? So those are spread out in the water, 3 LIs that are +1, 3 chlorines that are -1, and this is the precipitate. So you write VOH3 together, because that's the precipitate, right? This is the actual product, vanadium hydroxide. That's what you would see in the water. So now we Ghostbusters out everybody that's not vanadium hydroxide. Lithium, you're not, you're gone. Hydroxide, you stay. Vanadium, you stay. Chlorine, you're gone. Lithium, chlorine, you're gone. So now we've narrowed it down to just the net, just the profit, just what we actually made. And just what we actually made in this water is 3 OHs got together with a vanadium that was +3 to make VOH3, or vanadium 3 hydroxide. That is the net ionic equation. This is the only thing that actually happened in the test tube. Does that make sense? All right, people at home, if you're confused and you made it this far, I'm going to do it as an ed puzzle.